Hi everyone. So yesterday we had a lesson on sequences and series part 1. We looked at what arithmetic progression and geometric progression are. So this is just um, a picture of the few things we captured, right? And I gave some assignment. Yeah, I gave some assignment. So yeah, today I'll give you a similar question. Yeah, I'll give you a similar question to try. Your hands on. I'm coming. So I'm going to give you a similar question before we move on to what I have to do today. Get ready. Mm, Um, just a moment, guys. Let's write. So find yeah. So a new question. It appears many of you were not comfortable with fractions. I wish I could I could find an example. Mm, you will meet one. We'll meet one. So find the fifth term of the linear sequence. I got one for you. Of the linear sequence. So the sequence is 1/3, 4/5, 7/9, then 10/13. So this is also in a fraction. So let's look at that. Let me know if you are done writing. I will solve this with you. Let me know if you are done writing. With you. So why are you wasting your time to? Okay. If you can solve, do so, but please hold on. I like talking a lot. I like highlighting some important things. You hold on, hold on. Assuming I never told you it's a linear sequence in a question. Remember, going forward, you do GP, geometric progression, and now the question will appear as open, an open question. Now you might have to identify what sequence is that, right? So this is what you're going to do. To find out if it's a linear sequence, you just have to subtract the subsequent term from the adjacent preceding term. Do you understand? So you do U3 minus U1 and check if the answer you get is the same as U3 minus U2. You get it. Do 4/5 minus 1/3 and check if the answer is the same as 7/9 minus 4/5. Is the same as 10/30 minus 7/9. Do you understand?
Yes, sir.
Like do it on a calculator. So if it's a linear sequence, that's how you get to know, right? So if when you do it, what are you getting? Don't start solving here too.
That's 7/15.
Okay. If you say so. Don't start solving here too. Everything math is not about um I I do this and you are able to just copy the pattern and do same. No, it's about having the concept right. Okay, so she says 7 over 15. So you check for all the numbers listed if it's 7 over 15 throughout. Then you can confirm it's a linear sequence. Okay, so now I believe it's the same for all of them, right?
No, the next one is negative, negative 1/1.
Let me see,
7.
7 over 9 minus, that meaning there's a problem with the question. 7 over 9 minus 4 over 5. You see, so if you've not done that, you've started solving. Have you seen it? If you've not, the next one is wrong. 7 over minus 4. Yeah, meaning it's not a linear sequence. Let me check the question. It's not a linear sequence. We can't use it. But let me see if the question, I copied the right question. So it's not a linear sequence. Oh, it's not a linear. Check the other one. I'm sure it also differs, right?
Negative 1 over
It's
something.
also different, right?
Negative 1.
So it's not a linear sequence, it's a geometric progression. It's possibly that we'll get to it. You see, so many of you would have started solving and it would have been wrong. You see? Okay, so I have another fraction here. Let me check first before I give it to you. Okay. You see how things works. I'm confirming something. I have a fraction here. Let me check. Okay, I have one for you. Oh, really? No, I made it wrong. Okay, guys, so let's change the fraction. So 1 over 3, just imagine we would have started solving. Meanwhile, it's not a linear sequence. I formed the question myself though. I mean the preamble. The find the feed term, that preamble, I brought it up. Yeah. And I took some list of fractions from the book. Then 13 over 3. Little did I know it wasn't a linear sequence. Yeah, so let's use this. So you can check for this one. Okay, so now from this, so Jess, from this, you know your first term, right? You don't rearrange it. You have to maintain it the way it is. A is what? 1 over 3. Hmm? Then how do we find a common difference? You have to state your formula first, right? Who will help?
U2 minus U1.
He prefers that, which is fine. U2 minus U1. So that will be 5 on 3 minus 1 on what? 3, right? Then you can find the LCM, which is what? 3. 3 into 3 is 1. That'll be what? 1 times 5 is 5. 3 into 3 is 1. 1 times 1 is 1. Safia, 5 minus 1 over 3 is what? Safia, you're not following. I barely hear you.
Yeah, that's 4 and 3.
4 1?
Yeah, that's 4/3.
Yeah. So now you quote your formula to find the n term is equal to what? A plus n minus 1 what? D. A is 1 over 3 right? Plus n. Oh, I'm sorry. So I said find the fifth term, right? So U5 will be 5 minus 1. The common difference is what? 4 over 3. So you have 1 over 3 plus 4 times what? 4 over 3, isn't it? So that'll be 1 over 3 plus what? 16 over 3. LCM is what? 3. I need help. Venice. I almost forgot about her. Yeah, Venice. Is she there at all?
Yes,
So help me continue. Those whispering the answers, I'll come and lock you, man.
Hey.
Hmm. So some people are whispering values over there. Venice, I need help. What? You don't understand everything.
Fraction.
What don't you understand?
The fractions. Yes, I don't understand fraction.
You don't, and so why are you saying it now? Hmm? Why are you saying it now
Is it over?
and not earlier? So I've done a lot. Which part don't you understand? Specify that. We found a D here. Fractions were involved. We found the n term. Fractions are being involved. So let me know what part don't you understand?
Yeah. After the common difference.
Okay. So now they said we should find the fifth term. So the fifth term is given by the formula a plus n minus 1d. This formula was given yesterday, which you know. Now, so U5 will be A is what? Yesterday I said A, wherever you see A means first term. And in the sequence, the first term is 1 over 3. So that's what you see there. Plus N in the formula N is, of course, fifth term. So N will be 5 minus 1, right? N minus 1. D there is a common difference, which we just found out, 4 over 3. So 4 over 3. Let me know if you understand that step. This one.
That's good.
Then you
Yeah.
come to the next one. So I'm just copying 1 over 3 plus 5 minus 1 is 4. So 4 times. Already whatever was in the brackets is multiplying 4 over 3. So knowing the resolution for 5 minus 1, 4, I'll just multiply 4 to 4 over 3. Let me know if this step is clear.
Yes,
Then now 1 over 3 plus 4 times 4 is 16 over. Now listen, when you have a whole number, I'm giving you another tip again, right? This is what mathematicians know. When you have a whole number multiplying a fraction, the whole number only multiplies the top of the fraction. It has no business with the the denominator. So 4 will multiply the top, which is what? 16. So that'll be 16 over 3. Don't multiply it to the denominator. I hope it's clear. So 4 will multiply just the numerator. So 16 over 3. If you point on your calculator 4 times over 3, it will give you 16 over 3. Let me know if it is clear.
yes,
So now we have 1 over 3 plus 16 over 3. And I told you, if you have a fraction adding and subtracting another number, you find the LCM. Here is even two fractions. So LCM, what is common among them, right? So 3, so you write 3. If there is no number common among them, then choose the least closest number. Choose a number, but the least closest number, all of them can be divisible or can enter. Do you understand? So 3 can, of course, 3 and 3 is similar. So I choose 3. 3 into 3 is 1. So, oh, your time. 1 times the numerator is what? 1, right? Plus 3 into 3 is what? 1. 1 times the numerator is what? 16. Are you with me?
Yes.
Benes, you understand now?
Yes.
Let me finish up. So that will be 17 over 3. Yeah, so yeah. So that's a fifth term. You can choose to express it in a whole number. That's up to you. Any question?
No,
Benes, you
sir.
understand it now? Benes, I'm talking to you.
Yes, please.
You understand it?
Yeah.
Okay. So your time is up, but I want to say something. Are you ready?
Yes.
Um, so the answer you will get, the answer you get when you analyze the pattern of the sequence, 1 over 3, the next one is 5 over 3. You can see that we're adding 4 over 3 to it. When you sit down and analyze the sequence, you will be able to predict the next value. If you predict it properly, the answer you get must be the same as when you use a formula. So that's it. If you predict the answer properly, looking at the pattern, the answer must be the same as if you use a formula. So if you don't identify the sequence right, that oh, this is a GP or this is an LS, okay, linear sequence, this is an AP, then you just use the wrong formula, your answer will never match. So all the time, try apply logic to see what is next. Like use logic to identify the next number. Use logic. All the time, use logic. Okay. Then make sure when you use a formula, the answer matches. Okay. Guys, you see, this question here says dot dot dot. Many of the questions we've solved implies that, meaning it continues to infinity, right? There are some questions, they will list the numbers, they will leave what is in between them, but they will tell you what is at the end. They'll give you the last thing. And sometimes they can ask you to find a particular term in between. This is an example. This is an example. I'm closing you, and don't worry, this is what I will use to close you. Find the number of terms in the following linear sequence. In the following linear sequence. Okay, so we have 3, 7, 11, dot, 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 31. Then we have 2, -9, -20, dot, 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 -141. Okay. Guys, are you here? So you see, yes, 3, 7, 11, meaning there are numbers in between. That's why there's a dot, 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 right? Then all the way to 31, meaning I've given you the last 10. You can see that. The second one too, you have the last 10, right? So sometimes we can give you the last term and ask you to find a particular term, right? So so remember I gave you, you are all aware of this formula. To find the n term is a plus what? N minus 1d. I think you are busy writing. Let me know.
Yes.
Let me know
These
when
are
you're done. Yeah, so go ahead, read the question to me.
find the number of terms in the following line sequence, linear
No.
sequence.
Yeah. Okay, so the question is asking you to find what the number of terms, right? We've given you the beginning, dot 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 means there are numbers in between them. We've given you the end. So find the number of terms, right? So there is another formula I didn't give you, and you are being introduced to it now. Whenever you have the last term, you can use this formula. L equals A plus, it's the same thing, to investigate the number of terms, okay? Where the L there, L stand for what? Last term. Yeah. Yeah, that's all. So this question says the number of terms. Benis, you understand it, right? Is she there?
Yes.
You understand it when we say the question says find the number of terms. Okay, so
Yes.
first you quote the formula. You know that given the last term, I see last term there, right? So given the last term, then we can use this formula n minus 1 what? D. Then you can see that, oh, the last term is what? 31. So it's equal to A. What's the first term here? Well, that, no, Andrews. What's the first term?
Three.
What's that?
3.
Good. What's the N? N is what? The N term, like the number of terms. So do you know? No.
No.
Was, oh, you know, where to calculate for common difference. I apologize. But me, I have the speed, I have the chance to erase. You may not have that chance. I'm sorry. You know, I should have done D equals or U2 minus U1, which will be equal to 7 minus 3, right? Which will be equal to 4. Then now I can go on. So D is what? 4. So you have 31 is equal to 3 plus. And this is removing brackets in algebra, isn't it? The 4 will multiply every value inside the bracket. Dennis, can you try? So that'll be what? Remove the brackets. Dennis. Patience. Okay, she's on the floor. 4 and patience.
Minus 4.
What? I can't hear you. Come on.
Minus 4.
Minus 4. So you have, now you group light terms. So 31 here, right? You bring the
Yes.
3, so that'll be minus 3. You bring the 4. It's negative there. So if it's crossing the equal sign to be plus, so it will be equal to what? 4 what? In. What's the answer? 31 minus 3 is what? 28 plus 4, which is 32. Am I correct?
Yes, it is.
Okay. So it will be equal to 4n. Then you're looking for n, so 32 equals 4n. Safia, do you understand what we're doing?
Yes.
Okay. So n is equal to what? 4
8.
cancels for 8. So which means that the group of numbers 3, 7, 11, dot, 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 all the way to 31. The number of terms involved is actually 8. There are 8 numbers involved. And you were given 1, 2, 3, 4. 4 was given in a sequence. So how many numbers more do you require?
8. Oh,
Which one should I choose? 8, 4, which?
the correct one.
What do you mean the correct one? So I should use my conscience. No, I need you to answer me. Which one should I choose? I said now it's discovered in the sequence there are 8 numbers involved. In the question you have 4. So how many more is required in between?
4.
Say that again.
4.
Right. The next one is your assignment. I'm going to give you more. When I meet you, we'll do some of how we sum arithmetic progression, how we sum them. Yes. Do you have any question for me? Do you have any question for me?
No.
Okay, so this brings us to the end of this session. Have a nice day. Um,